So in this video, we're going to talk about volumes by washes for rotation about the y-axis. So what if I'm given, what if I wanted to find the area between the curve of y is equal to x squared, okay, and then y is equal to 2x? Well, again, graphing is not necessary, but it's helpful. So if I graph these two functions, okay, I know the graph of y is equal to x squared looks something like this, minus, well, okay, well, technically we have another one on the end here, but because my line y is equal to x2, it has a slope of 2, right? So so the line, maybe the line looks something like this, okay? Well, we're just at this point we're just estimating, okay? Well, I know the area between the curve is right here, okay? Well, what's my integration? Okay, well, if I'm integrating this about the y-axis, remember we said that when we're integrating about the x-axis, we walk along the x, and the integration is given by the upper, where the area between the curve is given by the upper function minus lower function. Okay, well, now because I'm walking with respect to the y-axis, so you can imagine if I'm walking with respect to the y-axis, from the axis to the upper function will be my radius. Okay, so from the y-axis to the upper function will be my radius. Now it's kind of hard to see here, but this line goes straight to the line of y is equal to, maybe we should say, so this is y is equal to x squared, and this is y is equal to 2x. Okay, so what's the integration? Okay, because I used a and b for my limits of integration with the x-axis, I'm just going to use c and d here. So what is integration? Integration is from c to d of pi x squared minus pi 2x to the fifth, 2x to the fifth, okay, dx, okay, dy, okay. So is this correct? No. Okay, I didn't really care about the fact that I put a 5 here. This is incorrect, okay, incorrect. And I just wanted to prove a point. Do not, with respect to washers and discs, which they're the same thing, do not integrate with respect to y and have your variables in x, or vice versa. That is wrong. Okay, so I did this just for a reason to show you. Now, so what is the real integration? Well, if I walk along the y-axis, I need a function of y. Okay, so right now the function is given in terms of x. I need my function in y because I'm integrating about y. So therefore, what does that mean? I have to solve for y. I have to solve for the function of y. So therefore, if y is equal to x squared, then x has to be the square root of y. So this is my function of y, which I'm going to play with. Now it's the same thing for the other one, right? If y is equal to 2x, that means that x has to be equal to y divided by 2. Okay, and these are my two functions that we're going to integrate with. So the integral is given from c to d. Remember we said it's pi. Well, what's my radius? It's the upper function. So my upper function here, yeah, because I'm walking with respect to y, and you can imagine if I turn the page this way, my upper function is y is equal to x squared. X is equal to the square root of y. Okay, so my upper function is the square root of y. Okay, and that's nice to know because we're going to square that. Okay, and this is minus pi. Well, what's my lower function? That happens to be y divided by 2, and we square that and we integrate with terms of y. So this is the correct formula. Okay, so this is the correct formula. So now let's look at the integration itself. Okay, let's look at the integration itself. Well, we got to find our upper limits. We got to find our limits, okay? We got to find our limits. So we got to find the values, the limits of integration with respect to y. So, well, what does that mean? Okay, well, in order for me to find my limits of integration, then I have to have my functions. I could set my functions of y that I got here. All right, so there's functions of y that I got here equal to each other. Okay, so if I set those equal to each other, then I have the square root of y is equal to y over 2. Okay, well, if I'm solving for y, I can't have the variable on both sides of the equation. So if I square both sides, then this becomes y is equal to y squared divided by 4. Okay, well, that's nice to know. So y minus y squared divided by 4 is equal to 0. Okay, well, because I have a quadratic, I'm always gonna put my highest factor in front because that's just how I like it. So this is y squared over 4 plus y is equal to 0. Okay, well, I don't like this 4 being here. Okay, I don't like this 4 being here. So if I multiply by 4 on both sides, I get negative y squared plus negative y squared plus 4y is equal to 0. Okay, so now that I have my equation in this factor, I could just factor out. So this is negative y times y plus 4. Okay, now this should be a minus. Okay, so negative y is negative y squared, negative times a negative is positive 4y, and that is equal to 0. So therefore my y is equal to 0, and y minus 4 is equal to 0. So therefore y has to be plus 4. So these are my two limits. These are my limits of integration that I'm going to play with. So now let's go to the integration and do the integration itself. Okay. So we know our limits of integration, and limits of integration is given from 0 to 4. Okay, of pi. Well, I'm just going to factor out my pi since it's pi r squared minus pi r squared. So this is pi times, what's our first function? That's the square root of y squared minus y divided by 2 squared, all right, dy. Okay, so let's do the integration now. Well, the square root of y times squared, that's just cancel. This is the integral of pi times y minus, well, that is y squared divided by 4. All right, and this is all dy. Okay, so at this point, I could just go ahead and take my integration. So, I'll just go ahead and take my integration. So this is the integral from 0 to 4. Let's not take it to 0. So this is given by integral of 0 to 4 of y minus 1/4. I like to factor out my coefficients. So this is y squared dy. Now if I take my integral, this is pi. What's the integral of y squared? That is y to the first. That is y squared divided by 2. And this is all being multiplied by pi minus, well, y squared, that is just 1/4 times y cubed over 3. Okay, and that is all integrated from 0 to 4. Okay, so now at this point it just becomes plug and chug. Okay, so this becomes pi, well, the upper limit is 4 squared divided by 2 minus 1/4 times 4 cubed divided by 3, and this is minus, well, if I plug in 0, I will get 0. Okay, does everyone see that? If I plug in 0 here, 2 divided by 0 is 0, and if I plug in 0 in for y, that's just 0. So this whole term this whole term back here is 0. Okay, so this now becomes pi, well, 4 squared is 16. 16 divided by 2, that should be 8. So this is minus, well, 4 cubed. Okay, well, right, so 4 cubed is what? Well, 4 to the 4 times 4 times 4 squared, and if I times that by 4, that's 64. So this is 1, well, if I multiply my 4, that's 112 times 64. Okay, well, that's nice to know. Okay, that is 0. Okay, so this becomes pi times 8, all right, minus 64 divided by 12. Okay, so that is minus 64 divided by 12. Okay, so if I simplify this, this becomes pi times 8 over 3. So my answer becomes 8 over 3 pi. Okay, so that's my integral. So what's the big picture to take away from this video? knowing that if I'm walking along the y-axis, I gotta be very careful. My upper function will change. It will not be the same. If I'm walking along the x-axis, notice that my upper function is now y is equal to 2x. But if I'm walking along the y-axis, my upper function is given by the square root of y. Okay, the square root of y. Okay, so that's the difference between the x-axis and the y-axis. Not much different. You just got to be careful of your limits of integration and how you kind of, but the general formula for just the y-axis in general is given by this whole video.